Good day, I'm Dave Fiak. I'm from Western Pennsylvania. I'm a trainer at Bosch. We're going to open up this box unit today for an installation. Chris, how about give me a hand with this and see what we can do and make it look good for everybody?
I would love to.
First thing we want to do is make sure we got the right model number. Make sure it's the right size equipment. Make sure it's to be the unit that we need for this application. And it is good, so we're going to go ahead and open it up. The first thing we want to do is cautiously, don't cut yourself with the plastic straps. We'll cut both straps. We'll set them aside, and we're going to pull the cardboard box up off this unit. You want to watch when you're doing this because there's a chance that the manual will come up with that. Actually, that unit is underneath. They wrapped it. Hold on one second. All right, I got my side. I'll bring your side up.
Okay.
Okay. And now we'll try to lift it off.
Probably want to do this slowly, huh? So we can find that service manual?
Yep, the service manual is sometimes laid on top of the unit. It can be lost in the quick removal. Just set that aside. We'll take the bag off. Guys, here's a disclaimer. Please don't put the bag over your head. That's a safety concern. I have the manual over here, Chris. It's on the side of the unit beside
I probably
the
want to
front
make sure it didn't end up in the box.
Yep, it did not. I will take that manual off.
So Dave, when you looked at this and said we had the right model, what size did you come up with?
This was a 4-ton unit. And why did we choose the 4-ton unit?
Why did we choose the 4-ton unit?
The biggest thing is for CFM delivery. We have a 4-ton delivery system, 1600 CFM, and we have to fill the duct system to get proper air distribution and static pressure. So we have a 4 and 5-ton air handler available on this size, and the 4-ton fits the need. It also worked out with the BTU loss and heat gain that we did. You have to always do heat loss, BTU, heat gain to make sure that the unit's correct. We just don't want to match up the unit we took out for sure and it's going to be the same, because sometimes those units will be miscalculated from the beginning.
So what size is our outdoor unit?
Our outdoor unit in this case is a 5-ton.
So you mentioned load calculation.
Right.
So we're going to size the unit to the load of the house.
We're correct.
Okay.
We do the heat loss, manual J.
Okay.
In this application, we have a 1600 CFM duct delivery system, so that's why we chose to go with 1600 CFM. So to get this off the rest of the way, Chris, I'll pick up my side.
Okay.
If you want to see if you can pull that foam and the cardboard off your side.
Might have to
There you go.
break this down a little bit.
Very good. And we'll just walk it off your side there then, if you want. There you go. Perfect. Get this stuff out of the way. Watch for nails on the board. You don't want to step on a nail and have that in your foot.
So as you can see, this unit comes as an upflow. However, we do have this model available in multi-positional. Upflow, downflow, or horizontal. And if we were to consult the IOM is going to tell us how to convert that from the current upflow position as it is from the factory to downflow or horizontal.
So guys and gals, one of the reasons we chose Bosch, one is the reputation Bosch has. It's a great product. And this unit is multi-position, as Chris had made it. It is multi-position, up, down flow. No accessories are needed. We can choose an application for this one that we can go communication. Communication-wise, we can have 2 wires with shielded cable grounded, and it will actually communicate back and forth. We can use it with the Bosch thermostat and the Bosch cloud, which actually takes room temperatures of what the set point is in actual temperature and calculates our airflow delivery based off the differential of those temperatures. Or we can choose a third-party thermostat and use that communication process again, not to the full extent, but we have sensors in the air handler that allow us to determine what the incoming temperature is and what the cool temperature is. And it regulates the fan for that volume of flow.
So Dave mentioned, a couple different communication methods. We've got the standard as it comes with a 2-wire harness for an M1, M2 connection. We do have an alternative method of wiring a thermostat. This does come in the goodie bag for the IOM, along with some plugs for the drain. We also have an adapter for an alternative heat strip kit as an accessory. Couple other goodies here, thermostat grommets and things of this nature. This is why I want to make sure that we do not throw this away or it didn't end up in the box, so that we have these pieces and items available to us.
We always have the manual with the unit. So guys, if you're putting in the unit in and you don't think the manual's there, it is sometimes stuck in the box. It'll be above the lid, above the styrofoam. So there's always a manual comes with that unit. At that point, we're going to go ahead and get ready to open up the unit and expose it. So
but before we do, let's talk about some other features and benefits of this product. This particular product, as previous models that we have currently in place, still has an evaporator coil that is aluminum. We now also still have a constant torque motor that's inside of this thing. However, there's been some changes made to that motor. It's now a sealed motor to limit flammability risk. Other than that, some design board changes to accommodate an A2L sensor that we'll talk about during the conversion process. But outside of that, and also an M1 sensor, so now we're able to measure return air temperature. That's another addition to this product. That's pretty much it. Not a whole lot of changes, but this one, as Dave mentioned earlier, is paired specifically to the outdoor unit as a completed or AHRI match.
One of the advantages, Chris, that this process has, it gives us the capability to offer 100% of heat capacity of this unit down to 5 degrees. 55,000 BTUs of output down to 5 degrees.
5 degrees?
5 degrees.
How low does it go from there?
It goes all the way down to -13 at 70% output capacity, approximately 38,500 BTUs at -13.
70% capacity.
At -13.
So what happens after -13?
It goes to -14. If there's a call for heat, it'll complete the call.
Okay.
Even to -15 or -20.
Okay.
But when the thermostat is satisfied, that unit will not start back up until it gets above -13.
The unit will not come back on until it gets above that.
-13. So that's sometimes an issue concerning your location. If it never gets that cold, that's not an issue. You know, Chris, one of the other things that come up sometimes, we have a lot of sometimes issues down in the Florida location where they'll mount these into a garage space. And because they do really great dehumidification and cooling, the units will tend to sweat. So there are some regulations that they recommend that we never install this over an 86-degree location. So if you're going to choose this in Florida in the garage, it's 95 degrees in there and 80% relative humidity or above, it will sweat, it will condensate. Sometimes it will require you putting additional insulation around the unit or encasing this in a box where they will put a little nick in the supply and a nick in the return to make that a conditioned space around this unit.
Okay. You know, earlier you mentioned communication. It's my understanding that this has multiple ways of communicating, whether it's our thermostat or somebody else's thermostat. Please talk about that for a second.
It does. So we have what we call our A version, which is kind of the easy way to go with someone else's product, in which we have the T1, T2 sensor involved. We still have a communication 2-wire that goes between the air handler and our outdoor section at that point. They're constantly looking at the temperatures and adjusting the fan speed based off of what's happening and the cool temperature and dehumidification based off the humidity set point of the thermostat and what the actual home is at that point. Option B is using the Bosch Cloud Bosch thermostat, the BCC 110. And with that application, we look at the actual temperature at the thermostat for what is the set point and what is the actual temperature. And that information is brought back through the cloud to the air handler, and it chooses its temperature with the compressor section. The third style is going to be one that's not necessarily a Bosch air handler, maybe not a Bosch coil. At that point, we have 4 conductor wire standard to all the IDS we've had before. We'd have our blue wire, which would be for our reversing valve. We have our brown wire, which is common. We have our white wire for electric heat. And we have our yellow wire for the compressor section. So that's what we have going on. I think we should probably get this up on a crate and get it ready to convert.
We should too, but I want to go back to the communication wire you mentioned. If we are able to use a communication, does that require a special wire?
It does, and this should be a shielded ground cable and ground on both ends. And polarity is kind of important, so you make sure you get the M1 on M1 and M2 on M2 at the indoor and outdoor unit.
Does the size matter? Conductor size?
18 gauge wires, really all the bigger you will need at that process.
All right. I think we're ready to pair this thing up with an outdoor unit.
All right, so Chris, what we're going to do is we're going to go ahead and pull the covers off this unit and see what we got inside. You can use a drill, the Bosch drill. The issue is sometimes we have a stripping the screws out. Not so much taking them out, but putting them back in. So there's only 2 screws that take off the top cover.
So when we talk about upflow, converting to downflow and horizontal, is the procedure for horizontal and downflow the same, or is there a couple of things that need to go a little bit differently into that?
Well, one of the things for downflow is the unit has to be flipped upside down. And for us to flip that unit upside down, we got to pull out the coil to make that happen.
Okay.
Let's go ahead and expose the coil. So this is where they talk quickly.
Or film really quickly.
I watch YouTube. So we're going to pull off all the screws. Hey, Chris.
Yes, sir.
What's this on the bottom of these 2 big knobs down here? What's that for?
That is the area for a filter.
The filter grill.
Factory filter, not necessarily filter grill, but filter section where we can slide in a 1-inch filter.
I'm getting there, boss. I'm old, but we're getting there.
I think too, based on, particularly what kind of duct system we're working with, whether or not at high static or low static, if we high static issue, maybe it might be best to install an external filter that a little bit higher MERV rating, perhaps. If we have a duct system that can handle it, but we do have the option. Now that we got the covers off, there's a few things that need to take place before we can actually take that coil out.
So what this coil is a multifaceted coil. We can go, as we see now, as a vertical upflow, or we can lay it down on the right, and it would be a right intake, left blow. Condensate pan is already set up for that application. If we were to make this a left blow, we would have to change the coil around so the condensate pan is on the bottom. Make sure we have that condensate pan set up properly. A couple other things to note about the Bosch. We have 4-row coil. A lot of the other coils might be a 2-row, 3-row. A little more volume, a little more capacity does a great job. Take a look inside the coil. This is a hydrophilic coating. That's a blue coating. Hydro is water, philic is plastic. The goal is to get the water off the coil as quick as possible. From that standpoint, we're going to have to take some of these wires off here, Chris. I don't know how we can flip that with them wires on there.
Do we know what these wires are just yet?
They're copper and aluminum. And yes, we do know what they're for. This is for the sensors, our T1, T2, and A2L sensor.
Okay.
Chris, you did a special on the A2L sensor. Why don't you talk about what that's there for?
I did. This has to do with that refrigerant mitigation. In the event that we have a refrigerant leak, we are going to, this sensor is going to trip and send a signal to the outdoor unit to turn the compressor off, and we're going to send a signal to the indoor unit, and we're going to turn the fan speed to high. This is going to allow us to dilute any type of refrigerant leak that may have taken place and disperse it into the household based on a minimum square footage. And during this process, important to note too, as mentioned in the IOM, that downflow or horizontal left or right, that sensor then now has to be relocated. As I also previously mentioned too, we still do have the aluminum coil, along with that factory installed regular TXV, non-adjustable.
And no EEV.
And no EEV on the indoor. The EEV is going to be in the outdoor.
Outdoor units, correct.
To control refrigerant in the heating mode.
So what we got to do now is we have to disconnect our leads that come into here at this point. So just these 3 that come up through here. So there's a grommet. There's one more wire tie on top I missed. You have to watch when you're cutting your stuff. You don't want to snip that wire accidentally, because then it's not a good day.
So we can't splice the wire back together?
No.
Not probably a good idea?
Not a good idea. If you have to, you can. So guys, we have our T1, T2 sensor and A2L sensor. They're actually located up on the board. They're marked as such, so you really can't make that mess up when you go to take them apart. Some of these have clips in, some don't have clips in. The T1, T2 does not have a clip. Those came out relatively easy. We'll pull them down through. You have to watch the grommet up here that we don't pull the end off when we're doing that process. There's one for you, there's 2. And now we're going to go for the A2L sensor. We'll wiggle it back and forth a little bit. There she comes.
Now that we have our sensors disconnected, we can now remove our evaporator coil so that we can reposition our furnace and slide it back in.
Okay, for us to do that, we got 2 screws down here on the pan. I think this actually comes out as a whole unit. Nope, it must come off there. We'll take these 2 off real quick.
So the 2 brackets got to come off first.
I believe so. I'm gonna show that.
Hey Dave, what's that yellow sticker down there?
That is an A2L sensor to let you know that this is a flammable unit to have caution.
Okay, so there's some special things I need to do and safety practices and all that good stuff.
You know, Chris, one of the things we didn't talk about, these coils do come dry charged with nitrogen.
Okay, that's good to know.
So if you pop these rubber caps out and there's no nitrogen, there could be a problem with that coil, just FYI.
I suppose, like maybe a possible leak.
Possible leak or something done at that point.
So we may want to try to pressurize it and see, or would we just go get a new coil?
Well, that's up to you and your rep, the firm, to make that decision.
Okay.
Whether you make the repair or just get a new replacement. So we're going to slide this out. Chris, I'm going to ask you to give me a hand just because I'm old and decrepit.
These things are actually kind of heavy.
So we're just going to set that off to the side.
And we're going to leave it there until we flip the furnace upside down.
So Chris, we got to take that sensor off so we can put that coil in. Would you be so kind to do that for me, sir?
Looks like it's just mounted with 1 screw.
That sensor comes off, and we'll relocate that inside the unit once we slide the case coil back in. Gentlemen, we have rails that this coil must slide into, and something that's kind of important, these units need to be relatively level, left to right for sure, left to right. If it's leaning one way or the other, water may not drain out of that pan. We will suggest a slight lean to the forward so any water's in the pan. We don't want water staying in the pan. When water stays in the pan, it gets bacteria, mold, and growth. So our goal is to get that pan clean and dry. So we will go ahead, Chris, if you'll be so kind to help me lift that bad boy up. I think you got it all, Chris. You're such a he-man.
It might. It's my understanding too, though, this has got to slide through some rails.
I got my side started if you're ready.
I think I'm in.
Wow. It's almost like it was built for that.
Looks like we got to reattach some brackets.
We got our 2 screws right here. So 2 screws in the brackets.
Okay.
There you go. You got them?
Hopefully you got some good arm strength here. Like you said earlier, sometimes a drill may not be good for this.
Yeah, I think a drill might be overdoing it, especially if you strip out the screws. You can't go back. So when it comes time to route these wires down, we're going to route these wires down along the pan, under this edge, and into the board. They don't have to go out of the unit. They can be done internally, and we will mount this coil as sensor as well. Why are we putting the A2L sensor underneath? Because refrigerant is heavier in air. It'll settle. We want to pick up that concentration level.
Okay, looks like it's in place.
Are you happy?
I am. It looks like we just need to relocate the harness now.
So what I'm going to do is I'm going to try to fish that down through over here on this side, behind that corner bracket. I probably should do that before we put that in there.
Do we need to loosen anything up?
It might be easier if you do, Chris.
Okay.
So right here in the corner, there's a spot. Hang on, let me go ahead, Chris, and do this. I think this is going to have to be done. To allow me to get that cable ran down through there. There we go. So working along this edge, you're just going to work it down through the edge. Keep tucking it back. Take the bracket out, fish it down through, and we're just going to tuck it back into that channel, just like that.
Might want to strap it here too.
We can do it with some wire ties.
And then we're going to do this with the other harness.
Trying to steady your view.
And we're going to bring that down through there as well.
And we have one to go. Nope, that stays down here, so we're good. Let's put that back together now. And we can wire tie them up a little bit later. Again, with the screw gun, I'd be afraid of stripping them out. So I like the idea of just doing it by hand. Sometimes it is a time saver with the speed drill, but if you strip out a screw, then you're screwed. Okay, Chris, we need to route those wires down through the grommet.
And since we relocated the A2L sensor, we did not have to reroute this one, so We're basically going to take all 3 of these.
And run them down through the
grommet.
And that's probably this one right here. I think it was in, Chris, the motor one. There you go.
Okay, if you want to grab those.
Oh no, Chris, I didn't know which ones they go where. Oh, they're marked. That's right, they are marked. They're color coded too. So we got a red, we got a white, and we got a black. I'm assuming the red must go on red.
Is there anything we need to do to protect this from possible water blow off?
All you can do at that point would be to insulate this box to make sure you have your pan. We're going to do our condensate up here, and you could have an additional tray that may be an option in that application as well.
I believe that additional tray would be installed right here. We want to make sure we don't get any water. In the event we have high static, any water or moisture below this deck possibly damage that control board.
There's a clip on the inside. So we're going to get these wires up.
While he's plugging those back in, we can start reassembling our coil access door. Hopefully,
oh, that came off of here.
It did.
Were you throwing them around? Oh boy. Guys, you make your connection. This is probably a good thing to show. When you're making these connections, you want to watch how much you put your heat on your braze joint, that you don't come in and do damage to the valve or the sensors that are in here, to make sure we don't melt anything or catch anything on fire. I have to get a screwdriver to push that up in, I think.
Is there?
There's 1, 2, 3.
The bulb on the thermal expansion valve, is it far enough in, or do we have to remove it?
I don't normally remove them when I braze them, but I don't put a lot of heat. I keep this pretty cool at that point to do that.
So we're going to do that with like a cold rag or something?
Absolutely, a cold rag, and make it very wet. And if you're going to do a B-style turbo torch, you have to watch your size because you can get a lot of heat. So it's all about what you feel comfortable with. Okay, I think I got the grommet back in.
Okay. We're going to reassemble this door here. You want to hold that side.
Let's get her on there first, buddy, before we go too far. Okay.
Stopping screws. A little tall.
Righty-tighty, loosey-lefty, Chris.
You know, another thing too that has been a great addition to our new product here is that we now are approving, if you want to catch that side, Dave, we're now approving mechanical fittings, okay? Mechanical fitting is going to be a press type fitting that now it would eliminate perhaps the need for a braze joint. And by doing so, we may need to connect that fitting on here before the door gets put on, okay? Pro Press, I believe is the name of it.
Pro Press, Mueller has them, Zoom Lock.
A couple different styles.
Now they're not made to go over the floral, so, the swedge. So if you were going to do that, you'll probably have to cut the swedge off, or you can braze on a small piece of copper and then go Pro Press. But again, it's the heat issue at that point you need to watch.
Okay, okay.
Yep. So we got some wire ties in here. Just go ahead and tie this up a little bit so we don't get in the way of our fan. Nice and neat. Did you put one around there, Chris? And we'll put one down here and make this nice and neat.
Now I noticed, Dave, this doesn't have any heat strips in it.
It doesn't.
What do we do about that? Are there heat strips available?
There are heat strips available. And guys and gals, it's up to your location. If you get to a situation where the temperatures can go below 13 below zero, you might want to look at having a form of backup, because these units can lock out when it gets to 13 below. It'll finish the call, if it's even to minus 20, but when that call is satisfied, the unit will not start back up until we get above minus 13.
Okay.
So that is a problem where you could have no physical heat in the home should you choose not to do any type of a backup. If you're in Georgia, probably don't need to worry about that. If you're in Western Pennsylvania, you probably need to worry about that.
But also too, Dave, shouldn't we worry about that for defrost?
Defrost is an issue with these coils. When we go to defrost, we put that unit back into AC mode. When it's running AC mode, the fan continues to run. It runs on low speed during that defrost cycle, but it will blow cool air into the home. Typically 50, 55 degree air possibly coming out of the unit for up to 5.5 minutes.
So we're probably looking at 5.5 minutes. And why do we have such a short defrost cycle?
Because of the way we generate our heat with the capacities of coil in here, this is going to be my source of where I get the heat from inside the space to go out to the compressor section to clear the coil, and we shut the outdoor fan off, which increases the heat. And that's another reason for the hydrophilic coating on the outside, is so that water leaves the coil very quickly.
Okay, okay.
So at that point, let's talk about some more things. How do we clean our coils? That's one good question. Guys, normally I'm going to say fantastic 409 simple green. Nothing very aggressive, no acid-based type of product. Low water pressure. Please don't use a 4,000 PSI pressure washer on that coil and bend all the fins flat, because then you are in trouble with this system. You know, Chris, something we need to talk about. What is the warranty in this air handler?
The furnace.
Air handler, Chris, air handler.
This air handler comes with a 10-year warranty. Okay.
That's 10 years from date of manufacture, but if you register this unit, it goes from the date of install. And guys and gals, with the Bosch system, if you are a platinum dealer, you get 11 years on parts. 90 days on labor if it's registered on install.
Okay, so we got to register it.
You got to register it. And you, the contractor, should register that. Don't leave it up to the homeowner.
And I believe there's a couple different ways we can register it.
There is. What's one of the easiest ways, Chris?
I think one of the easiest ways is if we had everything hooked up to our Bosch Easy Air app along with our gateway device, we're able to do it right from our Bosch Easy Air app cell phone in order to able to just click on a QR code and it registers right there on the spot. Other than that, we've got to do it from a website, Bosch Contractor Portal website, where we'd have to fill in some information on a computer and register it that way.
Very
but
good.
I believe the Bosch Easy Air app would be the best way and easiest way at that point.
Absolutely. Okay, let's finish it off and we'll go what's next. Let's put that cover back on. So we're putting our screws back in. One of the things we've got to be careful on the downflow application, if it's a downflow, the breakers on code, up is on, down is off. You might need to pull the breaker out of the electric heat kit and flip that breaker over so that up is on, down is off. That'll be one thing they'll catch you on code. Other than that, we're about ready to go with this. We like the idea of canvas collars on our ductwork between the units. The canvas collars are not for alignment purposes, but for sound attenuation. We're going to put a canvas collar on the bottom and on the top to have that sound not carry out through our unit.
So now we're ready to install it. Now that we've done the field conversion of the air handler into downflow, we're now able to connect it to the canvas collar, connect it to the supply air plenum, and finish the connections, refrigerant lines, get the outdoor unit set, run some lines, and be able to weld it all up.
I believe with electric heat, on the bottom of the unit, if you have electric heat, you can't put it on a combustion base. It has to be a non-combustion base, so if something would malfunction, we don't catch the home on fire. So we have to be aware of that non-composite base if we're going to do it in downflow in electric heat application.
Does Bosch have a combustible floor base, or is that something that you have to make?
I would say that's
out in the field?
aftermarket. I don't think Bosch has that. That is aftermarket as well.
Okay.
All right. Why don't we go and see what the compressor section looks like? Maybe we uncrate that.
Let's go unbox that. Absolutely. Now that we've got the indoor section taken apart, we're now going to work on the outdoor unit. And
once again, before we start there, we want to make sure we have the correct model number and capacity. It really stinks when you haul this unit down the stairs and something doesn't fit. There is a lot of information on our website. You can go and download either the brochure, checking an IOM, an engineering submittal sheet on specifications for sizes so we know what we're dealing with before we open it. So we are good on this one. We're going to go ahead and uncrate this one as well. Caution again, make sure that we don't lift the box off and throw away an IOM or other material that might be pertaining into that.
Do we know what size this is, Dave? This looks awful familiar in size.
It is a 5-ton heat pump on a 4-ton air handler. One of the new things that Bosch has is the capability to mix match a little bit of that capacity. In this situation, we have the 5-on-4. There is no manual here, so Chris has it in his hand.
Which
That's
we
a
found
good
right
sign.
here, right on top of the unit. A couple of key points here to note on this is we now have an alternate method. We talked about some of the different logics, or the 3 different logics. Logic A, logic B, and C. Logic C being regular conventional thermostat. And this would be the harness if we choose to operate it or connect it in that fashion. Otherwise, we're going to use the factory installed M1 and M2, which, as we said earlier, requires that shielded cable.
So we got some things down here tucked away underneath. This is one, it's the filter dryer. It needs to be installed. It is a bi-flow filter dryer that must be installed. That is a steel canister. If you braze that canister in and you burn the paint off the end bell, it will leak after periods of time. Prefer for me to have that filter dryer installed indoors out of the weather. We also have a red bag. Chris, what's this red bag for down here?
That looks to me like that is going to be the antenna. And we have a couple of different ways. It does come with a harness there. This antenna gets mounted on either side of the unit, preferably away from direct sunlight. There's a sticker that indicates exactly where it gets installed.
Here's the sticker right here for it. Or there's one over here.
And it just simply connects right here on the side of the unit like such. Again, preferably away from any direct sunlight, depending on how you spin this in relationship to the house.
Keeping it away from the walls is best. And guys, let's talk about that, a little bit of that communication. This is an actual cell phone antenna. It uses the Verizon cell phone network to communicate. It doesn't mean the homeowner has to have a Verizon cell phone or you, the contractor, but there has to be a Verizon signal at this location. We can demonstrate that on a unit over here that's hooked up. You'll see that we have an orange cover. That means we have that coverage. Our dimension are 29 by 29 inches. That fits through a 30 by 30 gate. That's one of the unique things with Bosch. This is a 20-SEER application unit that's relatively small. The Ultra unit makes it a little bit of a higher discharge on the fan, so this is 43 inches tall instead of being the normal 33 inches on the 5-ton.
So how exactly or why did we need to go extend this up so high?
So we get more airflow, better capacity across the coil. We have some really unique features we're going to talk about in here as to why we would want to do that and enhance the performance of this unit.
We had talked earlier about this unit being enhanced vapor ejection, low capacity at colder temperatures. Some of those things that go into that, like Dave just mentioned, was the new integrated outdoor fan. There are some other features. You know, we talk about enhanced vapor injection. We're talking about an EVI compressor that has been put in here. In order to get that enhanced vapor injection, a couple of devices or a couple components that we had to add to this to make that possible. One of those components is an additional EEV. We're going to label it EEVC. From there, we also have what we're going to call plate heat exchanger.
They call that the economizer. Is a brazed plate heat exchanger is the economizer.
Which is going to allow us to bring...
Think of this as a turbocharger supercharger. When I compress more air, I get more horsepower. When I bring my subcooling down lower, it's more dense refrigerant, and as a result, we get greater capacity. In a brazed plate, what it is, if you take a look, there are individual plates, and what happens on one side of the plate is refrigerant from this side. What happens on the other side of the plate is refrigerant from this side. So what we do is we offer the opportunity to either cool or heat a product without intermixing the gases or the refrigerant. And this is the key important component of the Ultra to make it successful. And Chris, what temperature does that start actually moving refrigerant through?
Well, not only did I mention we added an EEVC, which is an additional electronic expansion valve, we also added an extra solenoid. This solenoid activates at 50 degrees. 50 degrees or below, we're going to allow that cooler liquid to go pass through this heat exchanger and then further subcool it so that we can send low pressure, low temperature vapor back to the compressor to help boost capacity and compression ratio.
So guys, it's all about getting that liquid back to our coil to boil off, which is this coil outside. And if we have more dense, we boil more of that liquid off, we get a better enhancement. And that's part of why the fan is up here, which is a higher shroud, to move more air when it's needed from that standpoint.
And to furthermore keep track of that, that refrigerant, that flow, we had to add some additional sensors. For example, there's 3 additional sensors that were added to this heat exchanger plate. We've got a T6A, a T6B, along with a T7.
Very good. And one of the things we want to call to your attention to, I'm going to sneak back here just real quick behind you, Chris. Those who are familiar with the IDS are going to know that before we had 25 parameters. Today, on this one, we have 35 different parameters that we can actually read and see what's happening with this system. There are 41 fault codes available as well. These units are pretty self-diagnostic. They're going to point you in a direction of where the problem is going to be if you can understand that procedure. So these are awesome units. They work relatively well. I would urge anybody looking to get in this game to go through an actual training that Bosch offers and understand all the parameters of what goes on behind the scenes. One of the things that Chris talked about earlier today, how do we know this is a 454B? There are red plastic indicators on our fittings. These are supposed to remain on there at all times. Do not take them off when you do the install. This is to alert a contractor that this is not R410A, this is R454B. Do not accidentally place the long refrigerant in this application of this unit.
One other component that was added to this that I think kind of rounds up or sums up some of the features and benefits of this new cold climate heat pump, and that was the addition of a base pan heater. During that cold climate, we go through defrost. We've got some water drainage off of this thing. That's going to freeze. That's going to build up in the pan, and if we don't heat that up, get rid of it, then we're going to have potential ice growth inside, component damage, things of that nature. So
I've personally seen issues with that process, Chris.
As have I.
Where they don't have the water draining. If the water builds up in this pan, it will actually build ice between that U-bend and rip the U-bend right off the physical coil. If it rips the U-bend off the coil is junked. And guys, I'm not sure if that would be warranted at that point. So do your due diligence, get it up off the ground, allow water to flow freely from that unit.
Does that mean then we've got to get this up off the ground a certain height?
So realistically, they want you up above the snow level if you can determine that. Now, if you're in western Pennsylvania with a 7-foot snow drift, it's probably not going to get that high. But the reality is we want to be up at least 8 inches off the ground, maybe a foot, and we have different ways to go. We have the pump ups that we can put on there with the 4 corners. We have a Diversitech pad that has 8 different multiple locations. All these are pertaining to your area. The Diversitech pad will not work in Florida. It's not a hurricane-rated pad. So your locations will require what you do to make that process work.
Is there any benefit to us putting a pad in the middle? I give it a 5-point
There
reference.
is, and that's one of the things nice with the Diversitech. You have 8 actual adjustable rubber-mounted pads to slide wherever you want to go.
Okay.
And if there's one in the middle, that helps down on the harmonics. Harmonics is the noise of the compressor that vibrates and carries through. So we want to have that block up and make sure we keep our elevation up.
Besides keeping maintaining a 5-foot discharge clearance here, is there anything else we need to do with this product on discharge in the heat mode or in the wintertime?
We do. We want to make sure that our eaves are not going to have ice or water slide off and hit down on top of this unit. And I've seen some of our Bosch units out there where ice has actually hit it and dispersed into the coil, and there's no aluminum fin around the top of the unit. Sometimes the people will choose to mount them a little closer. We want 2-foot isolation. If you don't have 2 foot away from the wall, 2 foot away from the sides, there can be harmonic noises carried through that system. So if you have to go out a little further, then so be it. If you go on the gable end of a house, the gable end's on this part, there is no overhang, there is no ice fall off, so sometimes location is critical. These units are extremely quiet. You don't hear much noise coming out of these units. However, if you put this right beside a bedroom unit, if it's right next to an office where you work, there will be noises that you will hear, especially when it goes into defrost mode or in colder climate when our RPMs are higher and capacities. So location's critical.
So I'm guessing the design of this fan blade that I know you can't see, as I can see now, is going to help with some of that quietness.
It is. It is actually a serrated blade at the end, so it cuts the air instead of baffles it and pulses it. So that's a serration end on the fan. So with that being said, we're going to go ahead and put this up on a pump up or riser, and then we'll go from there.
And then we'll talk about installation.
Wow, Chris, how did you do that? 5 pop-ups, a cement pad.
Look at that. We're ready to install the line set.
Our goal is to keep this 8 inches off the ground so we have no issues with water freezing that coil and giving us issues.
So plenty of room for defrost water.
Absolutely.
Oh,
so
perfect.
Chris, let's talk about our line set. We got to hook that bad boy up. How much can we physically go?
We have this particular product, we've got as much as 150 foot of line set to work with.
150 foot?
150 foot. And of that, we got 50 foot vertical to work with. So depending on my horizontal length, that may affect my vertical length. So if I got long horizontal, my 50 foot's going to have to come down.
So Chris, we got 3 options on liquid line, correct? 3/8, 3/8, or 3/8?
No, just one
option, just 3/8.
Just 3/8 liquid line.
Oh my gosh.
If we got a 1/4 inch line or we got a 1/2 inch line, we're going to need to replace that line set. Okay?
We have no choice but to replace it.
No choice but to replace that line set.
And what's my suction line?
My suction line in this case is a factory 7/8 service valve, again paired with the 3/8 liquid valve.
So we can actually downsize our suction lines one size. We can move down to 3/4. If you do 3/4 suction line, you can lose up to 10% of your capacity.
That was going to be my question. Are we going to lose capacity at that
We
point?
can, depending on the length. If it's a short line set, probably nothing.
Okay.
We can use existing line sets up to 40 feet for 1/8. If we go over 40 feet for 1/8, it has to be changed.
So what about other line set engineering? I know in the past people have said liquid line solenoid, I need to add a crankcase heater. What about oil traps?
All that's built in, Chris. All of it's built in. We don't need oil traps. We have an oil monitoring package that every 2 hours, we're going to run this at near 100% capacity for 5 to 10 minutes to bring the oil back to the compressor.
So that's going to bring the oil back. Okay, so that's good.
Yep. We already have the crankcase heater built in. We have a pan heater built in. It's all in there.
So my evaporator can be on the ground and my condenser on the roof, and vice versa without oil traps.
Correct.
All right.
Correct.
Okay.
So our suction line, hot gas line, needs to be insulated.
Okay.
Liquid line doesn't have to be. It doesn't hurt, especially if you're putting this in an attic area that's unventilated. That would enhance the performance of that process as well.
So earlier we mentioned too that we now approve mechanical type connections.
So if we're going to go mechanical, my complaint on mechanical fittings, if you goof up one mechanical fitting, you're going to have to change that service valve. You're going to have to change the service valve, everything we're avoiding. You know, some locations, Chris, they have issues with this. I know one application up in Massachusetts, they have to have a fire watch. When you're into a building with a fire watch, you have to have someone actually stare at that joint for 1 hour to make sure nothing catches on fire when you leave.
Okay, but that's if you're going to the brazing route.
That's correct.
Yeah, okay.
So if you go mechanical fittings, you eliminate that issue with the fire watch, which is a big benefit.
Brazing route, we braze up the line set, let's say we're 150 foot, no vertical, or 100 foot and 50 foot vertical. Now what?
Well, I guess it's got time to check our line set to make sure we have no leaks.
Okay.
So we're going to do a pressure test, and this is critical, especially under A2L. Our first thing is to put a pressure test. We're going to say on these units 250 PSI. On the original 410s, they were 150. On the 454B, they're 250.
I was going to say the original was 150, so now we're up to 250.
250.
Okay.
So we're going to be very prominent with that. We're using nitrogen to pressure test.
Okay.
Chris, does nitrogen change pressure at all with temperature?
Well, it might a tiny bit.
It does not.
It does not.
It does not. So it stays the same, and that's the benefit of putting in your pressure at 250. If you have 250 nitrogen, if it goes to 0, goes to 80 degrees, it's still 250.
Okay.
If you see a leak, that's not good.
Okay.
Our second thing then would be to go ahead and then after we're sure there's no leaks, we're going to do soap bubbles. Okay. After we do that pressure test to ensure that there's no issues, we're looking for micro bubbles. Micro bubbles will be a small stream of white bubbles.
Okay.
Even after 5 minutes of time with that pressure, if you see a small stream, wipe it, reapply the bubble material, and verify again.
Is it going to hurt if I pressurize this above 250 pounds?
It can. It can. The issue is the service valves may let that bleed through into the compressor section.
Okay.
We've heard rumor of that. I've not seen it firsthand, but I've heard some rumor of that application. It is possible.
So stick to what the IOM says. IOM says 250 PSI should be plenty good.
After we're done with that pressure test and we did our soap to make sure there's no leaks, we're then going to go with our vacuum.
Okay.
We're going to hook up a vacuum pump. We're going to pull down to at least 350 micron. Now, 350 micron, guys, probably could take an hour or two at tops. If it takes over an hour or two, then your vacuum pump might really suck.
So we're talking deep vacuum.
350 micron. That's deep. It's not 50 micron, but 350.
But on a line set and evaporator coil only, we're not in a moisture environment. Should I be able to get lower than 350?
Probably you can if your vacuum pump is good, and depending on whether you're using quick evac hoses. So they make a quick evac kit that has the 2 3/8 hoses. They pull the valve cores out. They pull up really quick if you go that route. If you're doing standard, then maybe an hour or two. We're going to do a triple vac. A triple vac system is where we pull this down 350 micron. We're going to break that first vac with nitrogen. Our goal is to get that pressure above 0 pounds or 1 psi. Not looking at 2,000 psi, 1 psi of nitrogen. What happens with moisture in a vacuum, it turns to ice.
Yes, sir.
And if we don't get that ice back out of there, our POE oil mixing with the refrigerant forms a white wax. It gets between the superheat spring and my TXVs don't respond. So we're going to be a little forceful on getting the moisture out of our system. So we put that nitrogen in, let it sit for 5 minutes. At the end of 5 minutes, we're going to bring on a vacuum pump and we're going to pull vacuum number 2. While we're doing that, we can go inside and hook on ductwork, hook up thermostat wiring. So we're always being productive with our time. We're not sitting there watching a vacuum pump do its mission.
So in the event that I am a high moisture type climate in that particular part of the year, I'm going to go triple evac. If I'm not in that particular moisture type environment, deep vacuum's plenty adequate.
Yeah, I like the triple vac personally, but that's up to your call.
Okay.
Guys, the whole goal is to get moisture out of the system, and we got to be very professional about doing that process. So we pull our vacuum 2, we go back at it, or we down to our 350 micron. It didn't go above that 350 micron for 1 minute at 500. That's our decay test. If it goes above 500 micron in that first minute, then that means our vacuum's not good or not deep enough. When you pull vacuums in microns, you should be pulling from 2 different locations on that unit. A lot of people like to hook on the micron gauge right to the vacuum pump, and you're getting a fake vacuum. So we pull that second vacuum, it's good. We go back in, do some more magic in the air handler. We come back out, pull our third vac. And our third vac, we're going to go ahead and get down to our 350 micron. Then we're going to add our charge. And Chris, what is our charge add going to be per foot?
Well, this particular product comes pre-charged for 15-foot of line set. Since we just installed this, let's say 150 foot, we need to add 0.6 ounces. I think the manual actually says 0.59. 0.6, splitting hairs here, 0.6 ounces per foot after the initial 15
So how many ounces would that be, Chris?
Well, I'm going to go with a 50-foot line set.
We're going to subtract the 15 foot from the 150, which brings it down to 135. 135 times 0.6, we're coming to about 81 ounces of refrigerant.
You are much better at math than I am.
81 ounces is the maximum you should ever add on a 5-ton unit that we're working with. All right? That's with the 150-foot line set, again.
Okay. That's probably going to put us somewhere around a 15-pound total system?
Perhaps. Okay. So that is critical, guys. Too many people don't add that charge at the end. If we're 15 foot or less, we don't do anything with the charge. If we're over 15, we need to add.
So we're not going to have any problems with high pressure or anything like that if we don't subtract refrigerant?
If we don't,
on
that's
anything
correct.
less than 15?
Correct. We do not have those issues.
Okay.
Very good. So once we get that line set brazed in, then what? I guess it's time for electrical. And this is where I'm going to spend a few minutes with electrical. Guys, we're doing electrical. Electricity demands respect. We fear the unknown. We respect the known. Anytime you're working on a unit, always work in backhand first off and only one hand. Put the other hand in your pocket. The object is if something goes wrong and you get juiced, it goes here out the leg. It goes here out the leg. If you put 2 hands involved, it goes across the heart. 5 millivolts can stop that heart.
That's not going to be good.
It's a one and done. You don't get a second chance.
That's not going to be good.
So guys, caution is really demanded for electrical when we're working electricity.
So I got to be careful in this area is what you're telling me.
Absolutely. There are voltages hitting upwards of 380 volt DC. AC is alternating 60 cycles per second. DC is a straight shot. You will not let go. Your muscles respond to electric impulses.
Is there a part of the board where I might be safer than other part of the board?
All parts of the board should be treated with respect and fear. So we've got our points down here that we can actually work with our contacts down here to read that reading. That's important. We have our terminals P and N. P and N, we're on the board here to measure what is happening with that voltage. We've got to be at 42 volts or less on P and N before you put your fingers in that board. That is a safety concern again.
Okay.
So you always open up the suction valve first, then liquid line second. That way we don't have oil dispersing out of the compressor section. So it's always suction line first. Guys, when you open up these service valves, do not use a drill. Do not go crazy with it. There's a piano wire in there that stops the valve as you open.
Okay.
When you're pulling your vacuum, these valve caps need to be on that unit tight. If they're not on tight, you might have air leaking around the valve.
So can I use a regular Allen wrench on that, or do I need a special tool?
You can actually use a regular Allen wrench if you want to. It's a slower process, but there are ratchet wrenches out there.
Okay.
I think it's U-Weld has a product perhaps that fits them.
Okay.
But there's all
So
kind
it's
of stuff
quick
available.
method.
Correct. It's
Yeah,
a
yeah.
quicker method. But please don't take and run this thing up crazily and all of a sudden the valve blows out and say, hey, we got a defective valve.
Okay.
That doesn't happen. If you go to crack this valve and you back off, you backseat the valve, and refrigerant starts to blow out of the valve, that is a defective valve. If there's just 1 or 2 slight bubbles, that's not an issue of concern. Cap it. These are
Okay.
machine fit. They
Okay.
should seal up and have no issues with that point. Great point, Chris. Great point.
So now we got line voltage connected to this thing. We did talk a little bit of safety on that.
If we do line voltage, we're probably going to suggest to you having a disconnect out here. And we like a surge suppressor. That's my opinion, not that of Bosch.
Okay.
But a surge suppressor that's going to monitor that system. And we want something that's going to have like a contactor. So if there's a problem with the voltage, this board goes completely dark. I don't want to mention names.
You mentioned surge suppressor, but we're also talking about surge protector also,
That's
right?
correct. Correct.
Okay.
It does both.
Okay.
And we want something that has a permanent lockout. So if a problem occurs, it's going to shut down the system that the homeowner has an issue, and they're going to call you out saying, hey, my unit's bad.
Okay.
If you don't have something that has that permanent process, then what happens is that can reset. On most surge suppressors, when it goes the first time, the unit will continue to run, but you've lost your protection. If you lose your protection, the second surge takes out the compressor. Now the homeowner's kind of bummed that they bought a surge suppressor that didn't do their job.
Okay.
It did their job, but that means they have to go out daily looking for that light sensor.
Okay.
So line voltage needs a fuse disconnect or a disconnect out here with a surge suppressor so we can service this unit.
Which can also be in the form of a breaker, too.
It can be that
or a
process.
circuit breaker. Okay.
So
now
that's our line voltage.
So now we got line voltage applied to this thing. Now we got to, going back to our logic, right? We talked about 3 different logics. Logic A, logic B, and logic C. This thing comes default as communicating.
So we have an M1, M2 shielded cable that allows this to communicate to the air handler. And what that's going to do is allow that communication to regulate the fan motor in auto select. You have 2 ways to set that fan motor up, manual or auto. And in our communication, it is auto. And it has up to 4 speeds it can move from based on the temperature differentiation.
Okay.
And that is going to be for what we call A and B in our control scheme. A being a third-party logic thermostat, B being a Bosch BCC 110.
Okay.
Logic C means we're going to use the 4-conductor pin to hook up, and that was in the bag, correct?
That is correct.
The 4-wire, it plugs on the board, and then you go back to a conventional. We have a Y wire, which is going to be the compressor.
Compressor.
We have a B wire.
That's going to be reversing valve.
We have a white wire.
That's going to be some backup heat during defrost.
And we have a brown wire.
Actually, Dave, that has changed to a black
I
wire.
heard that.